So moving on to the next example, we have a rectangular prism where side EF, or length EF, is equal to 3, length FG is equal to 4, and the height of it, or this AE, is equal to 6. And they want the magnitude of the vector EG and the magnitude of the vector AF. Okay, so let's start with the magnitude of EG, of the vector EG. Now, if we draw this vector EG in the diagram, the tail of the vector is going to start at E, and the head of it will finish at G over here. So I just drew this vector EG. And they want to know the magnitude of it. In other words, they want to know what the length of that vector is. Well, if you think about it, let's try looking at this rectangular prism from a bird's eye view, so from the top of it. And if we're looking at it from the top, what we would see is just a rectangle with vertexes E, F, G, and H. And then we have this vector here. And since we know that EF is equal to 3 and FG is equal to 4, notice to get the length of this vector, we can just apply Pythagoras theorem because it's a right angle triangle. Right? We have a triangle, right angle triangle with a length of 3 here and a length of 4, and we're solving for x, or let's just say c. Right? So a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared, and then 3 squared plus 4 squared is 25. The square root of 25 would just be 5. Hence, the length of this diagonal here, this vector EG, is 5. So the magnitude is 5. So we solved the first one. Now let's move on to the next magnitude. So this AF vector, we have to find its magnitude. So again, the vector AF, its tail starts at A, and it's going to have an arrowhead at the vertex F. So let's picture looking at this rectangular prism from the side, where we're just looking at this face A, E, F, and B. So all we would see is this rectangle A, E, F, and B. And we want to know what the magnitude or the length of this vector is right here. Now AE is given as 6, and EF, this length right here, is given as 3. And we want to find out what the length of AF is. So notice again how we can apply the Pythagoras theorem because it's a right angle triangle. So we have this triangle here. We're solving for C, the hypotenuse, and we have 6 and 3. So that means A squared plus B squared equals C squared. So 3 squared plus 6 squared is equal to C squared. 6 squared is 36. 3 squared is 9. So them added together, we would get C is equal to the square root of 45. And we can also simplify this radical, so we'd have 3 root 5. That's the same as the square root of 45. So the magnitude of this vector AF is this square root of 45. Or if we simplify the radical, 3 root 5. Okay, so let's do a recap of what happened. So we had this rectangular prism. We were given the sides EF, FG, and AE, and we had to find the magnitude of vectors EG and vectors AF. So starting off with EG, the vector would be the diagonal of the top face of the rectangular prism. So looking at it from a bird's eye view, we would see only this face. So we'd see this rectangle of F, E, H, and G, and we know that its sides are 4 and 3. And we're looking for the length of this vector here, this vector EG. Apply the Pythagoras theorem, solve for the hypotenuse C, and we get 5. So the magnitude of EG is 5. Then moving on to the magnitude of AF, the vector AF would be on the side face of this rectangular prism. So pretending like we're looking only at that side face, we would see a rectangle AE, F, and B. And we know the length of AE and EF, and we have to find the length of this vector AF. So again, applying the Pythagoras theorem, we get a value of square root of 45, or simplified radical of 3 root 5. So that ends up being the magnitude of AF.